In this video, we're going to look at Astra DB and we're going to see how that integrates with vector data and how we can use this to build AI-driven applications that integrate with large language models. Now, Astra DB is a powerful and highly scalable database that's provided by DataStax, who are kindly sponsoring this video. And Astra DB provides vector-enhanced functionality on top of Apache Cassandra. And DataStax provide a fully managed platform that enables developers to focus on creating their applications. And of course, this is a big win for productivity. It takes away all of the maintenance overhead away from those developers and just lets them focus on creating new features. Now, this video will be split into two parts. In the first part, we're going to look at Langchain and how this integrates with Astra DB. And in the second part, we're going to build a Django application that can connect to Astra DB and use that vector functionality that's built in order to create a small AI-driven application. So let's get started, and we're going to start by looking at Astra DB, and we're going to see how to create a database, and we're going to see what capabilities it offers. Now, Astra DB is a fully managed cloud-native service that's provided by DataStax, and it greatly simplifies the development and deployment of applications that take advantage of Cassandra databases. Now, Astra DB is basically a drop-in replacement for Cassandra, and as it says on this resources page that I'll link in the description, Astra DB simplifies cloud-native application development, and it reduces the time to install, deploy, and scale from weeks to minutes. Astra DB eliminates the operational overhead involved in using Apache Cassandra, and that comes with great benefits for developers who can focus entirely on creating applications and can leave all of that operational overhead in managing Cassandra clusters to DataStax. This is a big win for developer productivity. So we're going to dive into Astra DB in this video. Cassandra itself is an open source NoSQL database, and this is a very powerful and scalable distributed database system that can handle massive volumes of data. And Cassandra is used by many big names in industry such as Netflix and Apple. I'll leave a link in the description to some case studies that involve Cassandra, but for now what we're going to do is we're going to get started with Astra DB, and we're going to see how to sign into the console or the dashboard that's provided by DataStax, where you can actually create your database and manage that database on the cloud. So what I'm going to do here is sign in with a Google account, and that's my email account, and that's going to take us to this dashboard page where we are now ready to actually create a database, as it says here. And we also have some guides and examples for different types of applications and functionality that can be built on top of Astra DB, particularly with this vector search capability that's been added to Astra. Now, we're going to create a database in a second, but it is worth noting that Astra DB and DataStax have a free tier, and as you can see at the bottom left, that's what we're on at the moment. And what that allows you to do is prototype and build small applications that use the power of Astra DB, and you can verify and validate that you are wanting to go ahead with Astra DB before you actually purchase anything. So it's a very good platform for building these prototypes and making sure that this is the route that you want to go down. It's a very powerful database as well. So what we're going to do now is go to this create database button, and what that's going to allow us to do is create a serverless database, and that can be one that is vector enabled, and that is ideal for applications that are taking advantage of modern AI approaches such as large language models. So let's give our database a name of 𝗕𝗓𝒑𝒑 database, and that's because we're going to be building a question answering application in this video. And we're going to give the key space a similar name here. We're going to call that 𝗕𝗓𝒑𝒑 key space. And a key space is analogous to a database within a relational database system. In a relational database, we have tables that contain data. With Apache Cassandra and Astra DB, we have these key spaces, and within a key space, we can have tables that contain the data that we're going to store in the database. And when you're creating these, you can click this link to learn more about key spaces in Cassandra. But for now, we're going to move on, and the provider is going to be Google Cloud Platform. And if you're using the free tier with Astra DB, you are going to have to use Google Cloud Platform, but if you are on the paid plan, you can use Amazon Web Services or Microsoft Azure. So let's select Google Cloud, and we're going to select the region of US East 1. That's the only available region on the free tier. And once we've done that, we can click the Create Database button at the bottom right of this modal, and that is going to start the creation process for this database. And you can see at the top the status of this database is pending, but it will be created and then once it's created we can make that connection to the database. And what we're going to use in order to do that is we're going to create a Jupyter notebook, and we're going to use Langchain in order to interface with this Astra DB database. And after waiting 1 minute, you can see the status at the top is now active. And what we're going to do now that the database is ready is we're going to go to this Connect tab at the top, and we're going to download some artifacts that are going to allow us to make a connection to this database. The first one is a token, and this is an application token that is used to securely connect to your Astra database. So let's generate a token with the database administrator role, and we can download these into a JSON file, and we're going to use that and reference that within our Jupyter notebook in a second. Once we've downloaded that, we're also going to download this secure bundle that's below here. So it's this one here. We have a secure connect bundle that's used when connecting to your database with drivers, and these bundles contain the SSL and TLS artifacts for your application. So let's get the bundle, and again we're going to select the region here, and what we're going to do is download this to a zip file. And once we've done that, we are going to move those files into the same directory as a Jupyter notebook that we are creating. So I'm going to go to the Jupyter notebook that I have open at the moment, and this is going to be the notebook where we bring in a data set and we create embeddings over the text in that data set and store those embeddings in Astra. And we're going to use Langchain and OpenAI to get those embeddings and integrate with the Astra vector database. So for now, what we're going to do is we're going to go to the directory that contains this Jupyter notebook, and those two artifacts that we downloaded, we're going to copy them into that directory. And I have that directory now open here with the two artifacts here copied into the directory. We have at the top here the zip file that is the secure connect bundle, and below that we have the database token, which is a JSON file. And also in this directory we have a .env file that contains the OpenAI API key. We're going to see how to use that later in the video. And this here is the Jupyter notebook that we're going to be working through in the video. So let's go back to that notebook just now, and later on we're going to reference those artifacts that we just downloaded. But for now, what we're going to do is we're going to get a data set, and this is the data set that we're going to use in this video in order to create the embeddings and store them in Astra. Now we're going to use the datasets library that's provided by Hugging Face in order to bring a dataset into this application. And the dataset that we're going to use is this one here. It's the CNN Daily Mail dataset, and I'll leave a link to this below the video. If we scroll down on this page, we can get a summary of the dataset. It's an English language dataset that contains over 300,000 unique news articles written by journalists at CNN and the Daily Mail. So we have more than 300,000 articles in this dataset. What we're going to do is write some code that's going to leverage this datasets library and allow us to take a subset of these articles for use in this application. But first of all, we need to install the datasets library. So what I'm going to do is bring up the Anaconda prompt. And if you're using a Jupyter notebook with Anaconda, then you can type in Anaconda prompt, and that should bring that up on your system. We have it open here, and what I'm going to paste in is a command that I'm going to grab from the blog post that we did on this topic, and it's this command here, the conda install command, and we're using the Hugging Face and Conda Forge channels to install this datasets library. So we can copy that and paste it into the Anaconda prompt here. I've already installed that, so I don't need to do that, but you can go ahead and do that if you want to follow along with the video. And then at the top we can import the datasets library here, and what we're going to do is we're going to write a function in Python that's going to bring this CNN Daily Mail article dataset into the Jupyter notebook. So let's write a function called load articles, and we're going to pass a parameter into that of n, and this is going to be the number of articles we want to extract from that dataset, and we're going to set that to a default of 5. Now the datasets library has a function called load dataset, so what we're going to do is we're going to create a variable called dataset, and we're going to use that datasets import and the load dataset function that's defined on that module. And the first parameter we're passing to that is the name of the dataset we want to load, and that's going to be the CNN Daily Mail dataset. And then we can pass some other arguments. We're going to pass a version for that dataset, and that's version 3. And you can get version information on this documentation here. And if we go back to the notebook, I'm going to pass another couple of arguments into this function. And to do that, I'm going to reference this page on loading a dataset in streaming mode using the datasets library. And I'm going to pass these two arguments here, split equals train, and we're going to set streaming equal to true. So let's go back to the notebook and paste that in here. And the reason we want to load in streaming mode is because this data set that we're loading is very large. So if we go back to the documentation for it, you can see here that it's 1.76 gigabytes, and that's a lot of text data to load into memory at once. So what we're going to do is load it in streaming mode, and this allows us to iterate over it directly without having to download the entire data set. So that's the purpose of the streaming equals true argument, and we're also adding the split equals train argument to this function. And once we've got that, we can move on and write the rest of the code for the function. Once we have the data set, we then want to extract n articles from that data set. So I'm going to store those in a variable called data, and we can use the dataset.take function and pass the n parameter that we have, which defaults to 5, into that function. And then once we've done that, we will have n articles available, and they have this particular schema that we have here where we have 3 columns, one for article, one for highlights, and one for the ID. What we need is only the article. We're going to take those articles and we're going to create embeddings on the articles. But what we need to do now is return just that particular column as a text field. So what we're going to do is return a list comprehension here. And for each article D in our data, we're going to return that article column from the data. So that's for D in data. And then that's going to return a list of text objects in Python. We can test this out by calling load articles and not passing any keyword arguments. That's just going to use the default value of 5, and you can see that they are downloading at the moment, and we should hopefully see them printed to the terminal when that is complete. And you can see once that's finished that we have the articles here. This one here is about Harry Potter star Daniel Radcliffe. So what we're going to do is we're going to take these articles that we're getting back and we're going to store them in a variable called articles, and then we can, for example, print the very first article out to the terminal, and you can see that appearing below. We now have these articles in the Jupyter notebook and they're loaded into memory, or at least 5 of them are. And what we have is the ability now to use these articles, and we're going to create embeddings using Langchain and OpenAI from this article data. So that's the next step in this video. Now again, I'm going to go back to the blog post that I wrote on this topic, and we have the code here. So if you need to copy and paste any of the code in this video, you can use the blog post for that. What we're going to do now is we're going to move on and, as I said, use Langchain and OpenAI in order to interact with OpenAI's embeddings endpoint to create embeddings from this text data, and then we're going to store that in Astra DB. But we need to install some packages first. So you can copy paste this command here into the Anaconda prompt, which I showed earlier on, and that should then install Langchain OpenAI tick token, which is an OpenAI tokenizer, and the Python.env library, which is used to read in the .env file that contains our API key for OpenAI. And you can see here as well, for the .env file, you have a key called OpenAI API key, and that should be set to the value of your key here, and you can get that from OpenAI's platform. Now once you've installed these libraries, what we're going to do is bring a couple of imports into the notebook. So I'm going to copy these in from the blog post. What we're importing here is the OpenAI embeddings object from langchain.embeddings, and we're also importing this load.n function, which we're going to call in this notebook in order to load the values in from that .n file into the environment. And what we're also going to do is we're going to create an object called embeddings, and we can do that by instantiating the OpenAI embeddings object. This allows us to pass a piece of text to OpenAI's endpoint and get back a vector embedding for that text. We're going to do that and store those vectors in Astra DB. So let's execute this cell in order to load in those environment variables. And what we're going to do next is we're going to create some chunks from those documents. So we loaded here 5 articles. We can verify that by taking the length of those articles, and you can see that that's equal to 5. What we're now going to do is take those articles and split them into chunks of a maximum size of 1000 characters. And in order to do that, we're going to use another object from Langchain, and it's the recursive character text splitter. And I'll leave links to the documentation for all of these objects just in the description of the video. What we're going to do now is create this splitter object by instantiating this recursive character text splitter, and to that we can pass a chunk size, and as I said, we want to set that equal to 1000, and we can also set a chunk overlap, and that's the overlap in the number of characters, or the overlap in the characters between one chunk and the next chunk. We're going to set that to 0 so that there's no overlap whatsoever. Once we have this splitter, we can create documents from the splitter by calling the splitter.createDocuments function, and we're going to pass those articles that we got back from the datasets library into that function. So that's going to take the raw text and it's going to create a Langchain document object from that raw text, and we can then take the document objects and pass them to another function, and that's going to give us back document chunks. So we're going to set that variable here, and we're going to use the splitter objects split documents function, and to that we can pass those documents that we got back by calling the create documents function. That's going to give us back these document chunks, and we can take a look at the very first chunk that we've got back here by indexing in at 0, and you can see we have part of the article referring to Daniel Radcliffe here. So we're not getting the full article anymore, it's been split into a chunk with a maximum size is 1000 characters. And what we're going to do, and the reason that we're doing this, is that we're going to store the vector embeddings for the chunk in the database rather than vectorizing the entire article. And that allows us to get more specific with the content that's being stored in each item in the database, because when we store a chunk we are splitting the raw document into a smaller subset which is more specifically geared towards a particular topic rather than the entire document, which is much more general. This allows us to narrow in on specific ideas and concepts that are available in a smaller chunk. So that's the reason for splitting these documents. We're now going to create embeddings from these documents and store them in our Astra database. And the reason we would want to do this is because every time we call OpenAI's embedding endpoint, that's going to cost us money in order to generate that embedding from the document that's passed in, rather than doing that over a knowledge base of documents that we always want to perform queries over. It makes more sense to create the embeddings once and store them in a database where they can be rapidly retrieved later on. And Astra DB has facilities to rapidly retrieve these objects and also to perform similarity comparisons between what's in the database already and a particular vector or query that's being sent to the database. We'll see that later on. But what we're going to do now is go to the Langchain Cassandra integration, and this is a vector store integration that's built into Langchain. We're going to use that in this video, but what we need to do first is install this library called 𝗏𝗏𝗏𝗏. So let's copy this command and go back to the notebook, and in this cell at the top here we're going to use the exclamation mark to indicate that we're running a command, and then we can run the pip install 𝗏𝗏𝗏𝗏 command. That's going to bring that into the environment for this Jupyter notebook. And once that's installed, we can clear that out, and now we can use this Cassandra vector store integration that's built into Langchain. Now, in order to connect that Langchain integration to our Astra database, we need to reference those artifacts that we downloaded earlier in the video. Now, I'm going to go back to the DataStax console here, and we're going to go to that database that we created earlier in the video. And we have the Connect tab here where we downloaded the application token and the Secure Connect bundle. What we can do is scroll down a little bit further here and go to the drivers section and select the Python driver. And there is some sample code that we can use if we go down to this part of the documentation. I'm going to copy this code that we have here, and we're going to bring that into the Jupyter notebook, and we're going to change some of the values that we're referencing. Now you can see we're importing from Cassandra.cluster this cluster object, and we're also importing a plain text auth provider from the Cassandra.auth module. And below that we're setting a Python dictionary where we have a key of Secure Connect bundle, and we're setting that to the name of the file that we downloaded for that Secure Connect bundle from the Astra console. Make sure that that zip file matches the name of the file that you downloaded. Below that we have a with open statement in Python where we're opening the token file. Now I need to change the name of this to match what the name of that file was that I downloaded for the application token. So I'm going to paste in now the name of the file that I downloaded, and that was TextQA database token.json. We're going to open that and load that JSON into a variable called secrets. And below that we're referencing the client ID and the client secret. We actually don't need to reference these because we're going to use the token instead. So what I'm going to do is paste another line of code in here, and we're going to look at that secrets which has a key of token, and we're going to extract that to a variable called Astra DB application token. And then below that, for the plain text auth provider, we're going to provide the token as the method of authentication, and we can pass that token here called Astra DB application token in as the second parameter. And finally at the bottom we're instantiating a cluster object and passing in the cloud configuration and the auth provider. And then we're using that clusters connect method to initiate a session with the Astra database. So let's execute this code, and when that has finished executing and connected to the database, we can take the session and we can get our session ID, which should return a UUID to us. So we now have a connection to the Astra database. What we're going to do is take these document chunks that we extracted, and we're now going to create embeddings from those documents and store them in our Astra database. So let's go down to a cell at the bottom here, and I'm going to bring in this Cassandra integration from Langchain. So let's scroll down, and what we're going to do is import that Cassandra integration. We can copy this import statement and paste that in here, and then we are going to create a variable which I'll call Astra vector store, and then we're going to call the Cassandra.FromDocuments function, and that allows us to pass in some documents to this function, and we're going to pass in those document chunks that we extracted, and I'm going to move these parameters onto new lines just so that they're clearer. Now, as well as documents, the Cassandra object takes embeddings, and we're going to pass in that instance of the OpenAI embeddings object that we created, and that was in this cell here where we instantiated OpenAI embeddings. We need that because when we actually create these documents and store them in the vector database, we need a mechanism for taking that text and creating the embeddings, and that's what this object here is going to provide. So we've got documents and embeddings. We also need a session which we can pass in here, and that's going to be equal to the session that we created by calling the cluster.connect method. So let's pass that into the Cassandra.FromDocuments function. And finally, we need to tell Langchain where these vectors are going to be stored. So we need to give a key space here, and we're going to set that to the key space that we created earlier on. That was the text QA key space. We also need a table name. So remember, a key space consists of tables in Cassandra. So we can give this table any name we want at this stage. So let's call it text QA vectors. Now we're going to execute this in a second, but there are a couple of small mistakes that I've made. This is called document chunks, and the parameter here that we've called embeddings, that should be called embedding instead. Once we've changed those, we can execute this cell, and we're going to see what happens when we do that. Now, just to summarize what this function should be doing, the Cassandra.FromDocuments function should take those documents that we extracted earlier on. It should send each one of those to the OpenAI embedding endpoint using this embeddings object that we created. That embeddings endpoint will then return an embedding or a vector for each piece of text that we send. And this Langchain Cassandra integration should then handle storing that vector along with other metadata into our Astra DB database. And the location where that data is stored is specified by the key space and the table name arguments. So now that we've done that, let's go back to the DataStax dashboard here, and we're going to test out to see if that worked by going to the CQL console. Now, CQL stands for Cassandra Query Language. It's very similar to SQL. Now, to start with, let's specify the name of the key space that we want to connect to, and it was text QA key space. Once we've connected to that key space, we can issue queries to tables within that key space. So I'm going to select count all from the table that we specified when we used the Cassandra.FromDocuments function. The name of that table was text QA vectors. So let's see what this returns. And you can see that that's returned a count of 21 rows. So that indicates that we have data in this table. What I'm going to do now is use another query, and that's the describe table query. And again, the table name is text QA vectors. That's going to give us back the schema of that table so we can see what columns are in the table. And we have a row ID, we have an attributes blob, we have the body blob, which contains the raw text from the document chunk that was stored in the database. We have a metadata map, and importantly, we have a vector column of data type vector. So this is a vector of floating point numbers, and the dimensionality of each vector is 1536. And that corresponds to the dimensionality of vectors returned by the OpenAI embeddings endpoint. So that's why each vector in our table will have 1536 numbers in that vector. So let's specifically select a few columns from the table. What I'm going to do is look at the body blob, and again that's going to be from that text QA vectors table, and we're going to limit this to a single row in the result. So let's execute that, and you can see the text that we're getting back here. It's a part of that article on Daniel Radcliffe, so we're only getting back one of the chunks when we execute this, but you can see that we definitely have data in this table after executing that Cassandra.FromDocuments function. And we can also take a look at the vector that's coming back for that particular document, and you can see we get back a large vector of floating point numbers. So we have data in this database, and that has been added here in the notebook by the Cassandra.FromDocuments function. So this is demonstrating how we can integrate our Astra database that is vector enabled with the Langchain library in Python. What we're now going to do is demonstrate how to query this database and how to find similar articles to a particular query that we specify. So what I'm going to do down here is we're going to take a look at the very last article from those articles that we fetched using the datasets module. And you can see this article is about an NFL star called 𝗵𝗽𝗽𝗍. And I'm going to take this statement here where we have 𝗵𝗽𝗽𝗍 is set to appear in court on Monday. And I'm going to create a query that is related to that text. So let's define a variable above called query, and we're going to set this equal to a question here. When will 𝗵𝗽𝗽𝗍 appear in court? And what we're going to try and do is we're going to try and use our Astra vector store, which is now populated with articles and the embeddings for those articles. We're going to take that and we're going to try and find the most similar or most relevant documents to this query that we've specified. So let's use our Astra vector store here, and we're going to call a function on that called similarity search, and we can pass the query into that function as well as a value k that is set to the number of the most similar articles we want to get back from that query. So I'm going to set that number to 2, and let's execute this function, and you can see the content that we're getting back. We get back 2 document objects, and both of these are related to the article on 𝗵𝗽𝗽𝗍. And the first article is deemed to be the most relevant, and that is making sense to me because we have this statement here, 𝗵𝗽𝗽𝗽 is set to appear in court on Monday, and that is directly related to the question. So this is the most similar document that's been returned from our Astra database, and that's been done by using a vector search over the database. The Astra vector store object has access to this embedding that we created earlier, and that will create an embedding from the query and then use vector similarity metrics in order to find the most similar documents from our Astra database. So you can see the power of the similarity search. We have a number of articles, but only one of them is anything to do with 𝗵𝗽𝗽𝗽𝗍, and that article has been split into different chunks. And when we call the similarity search method, we're getting back relevant content that is related to the query that we pass in. And what we can do with that relevant content that we're getting back from Astra is we can add that to a prompt that's sent to a language model as supplemental context to help the language model give us back a good answer to a question. That's a process called retrieval augmented generation. We're going to look at that now in this video. We're going to use OpenAI's GPT 3.5 model in order to get a proper answer to this query of when will 𝗵𝗽𝗽𝗽𝗍 appear in court, rather than just getting back the raw documents from the database. But we are going to get back the relevant documents and add them as context to a prompt that's sent to that language model. And that's a process called retrieval augmented generation. Now in order to do this, we're going to start by creating a retriever object in Langchain. So I'm going to create a variable here called retriever, and we're going to use our Astra vector store that we created with the Cassandra.FromDocuments function. We can use that and we can call a function called asRetriever on that object. And this retriever object is an interface into our Astra database for fetching the most relevant documents from that database. And by default, it's going to try and get the 4 most relevant documents, but we can pass a keyword argument called search_quargs with a value set to a dictionary containing a key of k, and then we can customize the number of articles or documents that we want to get back for this retriever. And I'm going to set that to 3 here, and let's execute this to get back the retriever object. So the retriever is going to handle getting the k most similar documents from our database. What we now need to do is set up a RetrievalQA chain in Langchain. So I'm going to go to the documentation for Langchain on using a retriever, and I'm going to copy this import at the top, and I'm going to paste that into this cell in Jupyter Notebook. We're going to import the RetrievalQA chain from Langchain, and this is what's used to perform retrieval augmented generation. We're going to see how to do that now using this chain. I'm also going to bring another import in here, and that's from langchain.chatModels. Let's import the chat OpenAI model. Now we're going to instantiate that chat OpenAI model below here, and we're going to set a temperature of 0, and we're going to specify the model as the GPT 3.5 Turbo 16K model, and the 16K refers to the token context window. This is the maximum number of tokens that we can pass to the language model in a prompt, and we need that to be quite high because we're using a retriever to fetch relevant articles from a database, and we're going to add those most relevant articles as context to our prompt that's being sent to the language model. So we have a large context window, so it's easy to fit the retrieved documents into that context for a query. So we've set that LLM object. We're now going to use that as part of the RetrievalQA chain. So let's set a variable here called QA retriever, and we're going to use the RetrievalQA chain's from chain type function, and I'm going to pass a number of keyword arguments into that function. First of all, we need a language model. We're going to set that equal to what we instantiated above here. We also need a retriever here, so I'm going to set that retriever that we created on the cell above here by calling the vectorstore.asRetriever function. And finally, we need a chain type here. I'm going to set that equal to a chain type of stuff, and that chain type will basically take the documents that have been retrieved from the database, and it will just stuff them into the context and add them into that context that's sent to the language model. So it's adding the entire K documents, in this case 3 documents that have been retrieved, into that prompt and sending that to the language model. That's the purpose of the stuff chain type in Langchain. So let's execute this cell to create that QA retriever object, and then in the cell below we are going to run a query here, and I'm going to use the query that we defined earlier in this video. That's this one here about when Michael Vick will appear in court. And let's just paste that in here so we can see it clearly, and we're calling the retriever's run method and passing that in. So let's execute this cell, and this function is going to tie everything together and perform retrieval augmented generation by fetching the most relevant documents from the Astra database, just as it did up here, but instead of just returning those to us when we call the similarity search function, what this is going to do is it's also going to call the language model and add those documents as supplemental context. And this time we get back a proper answer. Michael Vick is set to appear in court on Monday. So you can see here using Langchain and Astra how easy it is to perform retrieval augmented generation. Astra DB is capable of storing high volumes of vector-based data, and we can then perform similarity search over that database based on user queries that are passed in, and then take the most similar or relevant documents and add them as context to a language model in order to help us with our question answering applications. So we now have an Astra database that's populated with text and vector data, and we can use Langchain to query that database and get back similar or relevant documents, and then pass those documents as supplemental context to language models. In the next section of this video, we're going to build a Django application around this functionality, and we're going to show how we can connect Django to Astra DB and how we can create a small application that integrates with Astra and Langchain in order to perform customizable retrieval augmented generation. Now for this section of the video, we're going to be extending a GitHub repository containing some starter code, which is basically a Django application that contains some settings and some code that we've already developed in the notebook environment. And also for this section of the video, we have a blog post that is specific to the Django integration with Astra DB. I'll leave a link to both the GitHub and the blog post in the description of this video. Let's now move on. What I've done is I've cloned this repository to my local machine, and I have that open here, and we're going to walk through some of the settings and some of the code that we have in this repository, and then we're going to get started with the integration between Django and Astra DB. Now to start with, we have an example.env file containing 3 values. We have an OpenAI API key that's going to allow us to connect and send requests to the OpenAI API. And we also have 2 artifacts from Astra DB. We have the Secure Connect bundle and the application token. Now we saw that in the earlier section of the video, but just to remind you where you can find that, if we go to the Astra DB dashboard here, we have this database that we've created and we're connected to that database. If you go to the Connect tab, you can download these from this particular tab, and that can be downloaded and stored locally on your machine. But in order to follow along with this video, what you can do is create a folder called Astra Artifacts and place the 2 artifacts in that directory, so you have the Secure Connect bundle and the application token in that directory. And then you can fill out the names of these settings in the .env file with the names of these particular files. Now the reason that we're doing this, if we look at settings.py, is that we're calling the load.env function from the python.env module. That's that's going to load in the values from our real.env file, and it's going to load them and allow us to access them in the Django settings file. If we scroll to the very bottom of the settings file from the starter code, we have a number of Astra related variables being set. And this one at the top here is called the Astra artifact path. We're setting that to the Django base directory and then a subdirectory within that called Astra artifacts. And that is what we have on the left hand side here, where we've placed the two files that we've got from the Astra dashboard. So if you want to change the directory in which these are stored, you can change the value here, or you can change the value of this setting. But we're referencing those two files in the next two settings, the secure bundle path and also the database token. And we're using the os.environ.get method. Remember, these environment variables have been loaded in from the .env file by the python.env module. So we're setting the two references to these files here, and then we're going to use them down here in the cloud config where we set the path to that secure bundle. And we also have two other variables here. We're setting the Astra DB key space and also the table name that contains the vectors that we populated earlier in the video. And much of this is just copied from an earlier section of the video. Finally here we are loading the database token into memory and storing that in a variable called secrets, and then accessing the token key that is stored in a variable called Astra DB application token. And these variables are important because we're going to use them to connect Django to our Astra database, and we're going to do that using a library called Django Cassandra engine. Now before we do that, just to understand the setup of this repository, once you've cloned the repository, you should create a Python virtual environment, and then you can install the packages from this requirements.txt file. And there's quite a few different requirements in here. Some of them are specific to Cassandra and Astra DB. For example, the Cassandra driver here, but we also have the Django Cassandra engine. And this package is going to allow us to create a setting that is going to connect to our Astra database, and it's also going to allow us to create model classes that are very similar to native Django models that can model the data that we have in Cassandra. We're going to see that later in the video, but for now what I'm going to do is define a databases setting, but I'm going to go to the documentation for Django Cassandra engine in order to do this. As you can see, this is the Cassandra backend for Django. And of course, Astra DB is fully compatible with Cassandra, so this is going to work with our Astra database as well. And this contains a number of utilities, but what we're going to do is we're going to follow this basic usage section for now, and we're going to add the Django Cassandra engine as the first installed app in our installed apps list. So let's copy this line of code here and go back to VS Code, and just at the bottom of settings.py from the starter code, I'm going to paste that line of code in, and that's going to add Django Cassandra engine to our installed apps, and that's going to allow us to use the utilities from this library in the Django application. Once we've done that, we can go back to the documentation here, and you can see that we can change the databases setting in Django. Now, by default, that's going to point to an SQLite database when you first create a Django project. I've removed that code from the starter code, and now we're going to fill in the databases setting in this application. So in order to fill in this setting, I'm going to go to the blog post, and I'm going to scroll down to the section on connecting Django to Astra DB, and we're going to copy this databases setting that we have here in the blog post. I'm going to go back to VS Code, and we're going to paste that underneath this installed apps. I'm going to make the terminal smaller here, and we're going to look at this databases setting. So what we're doing is we're setting the default database in Django, and we're specifying that the engine we want to use for this database is the Django Cassandra engine. And of course that refers to this library that provides a Cassandra backend for Django. So we're referring to that, that's the engine for this database connection. We also have a name, and we're setting that to the Astra DB key space. And this name setting is analogous to what you would set the name of a database to if you were connecting to a normal relational database. The Cassandra equivalent of that is a key space, so we're setting that equal to that text QA key space that we set in the earlier part of the video. So that's the name of the database. We're setting the user just to a string of token here because we're going to connect using a token. So we're setting the password option to the Astra DB application token, and that's what we've extracted from the secrets file here. That's what we're using to make that connection. And finally, we are specifying some options for this database connection, and we have a few nested dictionaries here. We have one for the connection, one for the cloud connection that we're making here that references that secure connect bundle and sets it to the path, and that's the path to this zip file that you can see in the Astra artifacts directory. So our databases setting is specifying that by default we're going to connect to Astra DB at this particular key space, and and we're going to use the token and the secure connect bundle in order to make that connection. Now that we've done that, we can save settings.py and we're going to test out whether or not this connection works. So I'm going to bring up the terminal here and we're going to run one of Django's management commands, and that's the shell plus command, and this is actually provided by Django extensions. And you can see when we run that, we're actually getting an error here that we can only concatenate a tuple, not a list to a tuple. And the reason for that is that we're using a tuple here that we've copied from the Django Cassandra engine documentation, but we can actually make that a Python list instead. So once we've fixed that, we can clear the terminal again and rerun the shell plus command. And when the shell loads, what should happen is it's going to evaluate all of these settings and it's going to try and instantiate that connection to the default database. But in order to verify that, what I'm going to do is write some code in this Django shell here. Now in Django we can get access to a connections object that represents our database connections. So we're going to import the connections from Django.db, and then I'm going to set a variable called connection, and we're going to set that equal to the connections, and we're going to index in, or rather we're going to get the default key from that connections dictionary, and that's going to return to us this database wrapper, and you can see the vendor is set to Cassandra. Now we can get a cursor which we'll call C from this connection by calling the cursor method. That will return to us this Django Cassandra engine cursor wrapper object. And with that we can execute queries using the Cassandra query language CQL. Now I'm going to set a variable here called result, and I'm going to call the cursor.execute method, and to that we can pass a string which is basically a CQL query, and I'm going to pass in a select query here to make sure that we have the connection to this database table that we're going to specify and that it is capable of returning data with the Django Cassandra engine. So what we're going to select is that body blob column, and that's from the table called text QA vectors, and I'm going to limit this to a single result that we're going to get back here and store in the result object, and we can get the actual data from that by calling the result.all function. That's going to give us back that data which we can then look at, and you can see we are getting back some text data. So this indicates that we have a successful connection to our Astra database, and this default connection that we specified in the settings.py file for the databases, this is working and we're capable of getting and fetching data from Astra. So that's important before we go on. We've verified that this databases setting is set up correctly and that we have a connection using that application token and also the secure bundle path. Once we've done that, we can exit out of the shell, and what we can do now is create a Django model class that's going to model the data that we have in that table containing our text and our vector data. Now we have in the Django project here an application which I've called QA app, and within that application we have a models.py file which is currently empty. We're going to fill in our model class in this file, but before we do that I'm going to go back to the Astra DB dashboard here, and we're going to go to the CQL console, and we're going to discover or query for the exact schema that we have in this database, and we're going to pick the fields that we want to represent in our Django model. So on this console I'm going to select the text QA key space using the use command here, and then we're going to perform a query that's going to describe the table that we have containing those vectors. So we're using the describe table command, and the name of the table is text QA vectors. And this gives us back the schema that we saw earlier in the video. We have a row ID, we have an attributes blob, a body blob, and a metadata map, and our vector field containing the vectors. Now for the purposes of this application, we want to let users in our Django app view the articles that have been stored in this database. So we only need to look at the text that's stored in this database table. We need the body blob, and we're also going to bring out the row ID here. So we're going to keep this simple, and we're going to specify a subset of these fields. We don't need the vector in our Django application. That's not required to show these articles to the user. However, you can also bring the vector field out if you'd like to as well. So what I'm going to do is go back to models.py, and we're going to see how we can create a Django model class that is going to use the Django Cassandra engine rather than the normal Django model class. Now we're going to use a few utilities from Cassandra here. So I'm going to go back to the blog post, and I'm going to scroll down to this section on the Django model for our Astra DB table, and we're going to select these two imports from this statement here, and I'm going to paste that in at the top here. We're importing columns from Cassandra.cql engine, and we're also importing the Django Cassandra model, and that comes from the Django Cassandra engine module that we're using to make our connection here to the database. It's the same library that we're using here for our engine. In the models class, we're going to look at the Django Cassandra engine's models submodule and import the Django Cassandra model here. So what we can do now is create a class, and we're going to call that class TextQA_Vectors, and that's going to inherit from that Django Cassandra model. And for now I'm going to pass, but what we're going to do is explain the naming convention here. This is a camel case version of the table name that we want to connect to with this model. So you can see the Astra DB table name, text_QA_vectors, and that's in the standard Python snake case. What we're going to do in the model class is we're going to change that to camel case. So we're getting rid of the underscores and we're capitalizing the first letter of each distinct word. And that gives us a class name of TextQA_Vectors. Now within that class we can specify the key space using the __ key space field. And we're going to set that equal to TextQA key space as per the database that we've set up. And then we're going to set up some fields on this model, and we're going to integrate those fields with this columns object that we're importing from the CQL engine. So we need a primary key, and that was called rowID, and we're going to set that equal to a columns.text field, and we're going to pass the primary key equals true keyword argument there. So that rowID, if we go back to the DataStax console here, that comes from this text field, which is the primary key for the Cassandra table here. So we are setting that and modeling that in this Django model as a rowID field that is a text column with the primary key equals true keyword argument. Now we also want to bring in the 𝗿𝗏𝗶𝗹 here, so I'm going to set the field name of 𝗿𝗏𝗶𝗹, and that's going to be a columns.text field as well. We don't need to pass any keyword arguments into this field. We can just keep that as a normal columns.text field, and we can save the file now. So this is a model class that subclasses the Django Cassandra model. We're now going to test this out using the Django extension's shell plus command. So at the bottom we're going to execute that, and we're going to test out whether this is capable of fetching data from the database. So we have the shell open here, so I'm going to use the model name, which is TextQA_Vectors, and as per normal Django models we can use the .objects.all command and see if that returns a set of objects. And you can see that what that returns is a Django Cassandra query set object. So could we get the first model from that query set by calling .first? If we execute that, you can see we get back a model class here that contains the rowID and also the 𝗿𝗏𝗶𝗹, and that was the two fields that we added to the model class. And this is capable therefore of fetching that data and displaying it to us in this terminal. Now on the blog post I've also shown some integrations with a vector field as well. This is a bit more tricky because the CQL engine's columns module does not contain a vector type, but we can set this to a text type, and then if we have installed a particular version of the Cassandra driver, that will convert that text data to a Python list that represents the vector. So if you want to know more about that, check out the blog post. For now, we don't actually need the vector in this application. We are going to use the vector functionality just a bit later in this video in order to fetch relevant documents from the database. But for now, we're going to go back to VS Code, and I'm going to exit the Django shell here, and we're going to go back to the application. And now that we have this model class, what we're now going to do is go to the views.py file, and we're going to import that model and fetch all of the article chunks that we have in the database. So at the top of views.py, let's import our Cassandra model class here, and what we're going to do in the context that we're sending to the index.html template is we're going to set a key here called articles, and we're going to set that equal to TextQA_Vectors.objects.all, and that's going to return that Django Cassandra query set object that we can then iterate over in the template. So let's save this, and we're going to open our index.html template. Now this is part of the starter code. It just contains a piece of text at the moment, and it extends a base.html template. And we can take a look at the base.html template and we can see what this contains. Within the head tag we are loading the CSS for Bootstrap 5, so we have access to some CSS within this project. If we go back to index.html, we're now going to clear out this hello, and we're going to display each article on a page in our Django application. So just to start off simple here, I'm going to create a template for loop, and we're going to iterate over each article that we have in that Django Cassandra query set that we're getting back from Astra DB. And don't forget to end that for loop at the bottom. And within the for loop, I'm going to set an h1 tag, and we're going to specify an article number here, and we're going to use the for loop.counter construct from Django. And this counter simply counts the number of iterations that the for loop has gone through at the given time. So we can close the header1 tag, and then just below that we're going to create a paragraph tag here, and this paragraph tag is going to reference the article that we're iterating over, and we're going to access the 𝗿𝗏𝗶𝗹 field. and we can close the paragraph tag here and save the template. And we're now going to start Django's development server. We can do that with the python manage.py run server command. That's going to start the server up at localhost 8000, and we can go to the browser and view this page. Now in order to view this page, we have a URL that is currently empty, so it's going to be at the root URL of this project. So let's go to that page now, and we're going to see that we have all of the article chunks that are coming back from Astra displayed in our Django application. So this is demonstrating how we can take a Django app, connect to an Astra database, and then fetch data from that database and display it on a page in our Django application. Now these are not complete articles, they are actually the 1000 word chunks that we extracted using Langchain earlier in the video, but these are going to work for the purposes of this video. Now what I'm going to do just now is style up this page a little bit with Bootstrap. So let's go back to index.html, and I'm going to add some code into this page. To begin with, we're going to create a div with a class of row, and we're going to split the page into two columns. The first column is going to have a class of column 8, so this is going to take up 2/3 of the page, and that is going to contain our article objects. So let's close these divs at the bottom here, and don't forget to close the row as well as the div with a class of column 8. We're going to create a second column here, and that's going to have a class of column 4. So this is going to take up 1/3 of the page, and this is going to contain something that we're going to add later in the video. So I'm going to paste a comment here for now. We're going to add a form that's going to let users submit a prompt here, but that's going to be done a little bit later in the video. So let's focus on this column here for now, containing our articles. So rather than having these articles just rendered one after the other in h1 and paragraph tags, I'm going to create an unordered list and use the Bootstrap list group class to give that some style. And under the for loop, we can close off that unordered list. And for each article that we're getting back from the Astra database, I'm going to create an li tag here with a class of list group item. Again, that's from Bootstrap, and we can tab the other content into that li tag and then close that off just below. And finally, the h1 tag, I'm going to add a class of text success, and that's going to color that title a little bit different from the body. And to the paragraph tag, I'm going to give it a class of font weight light, so it's going to appear a bit lighter in the context of this page. So let's save this and go back to the page showing the articles. We're going to refresh this page, and you can see now we get some different styles. It's nothing amazing, but it's a little bit different. We have the headers with a different color, and we have each article in a list element, and that's from top to bottom on this page. Now on the right hand side, we are going to add a form that allows users to submit a prompt. And we basically want all of these articles that we have to form a knowledge base, and we want to ask questions of these articles and have them answered by our retrieval augmented generation process. But we're going to allow the user to submit the prompt here, and also to customize the style of the response that they get back from the language model. And Astra DB is going to be in the middle of this process, tying everything together by allowing us to fetch these relevant documents from our knowledge base in the database. So let's now move on to the next part of this video, where we are going to look at question answering with Django, Astra DB and Langchain. Now we've copied much of the code from the previous video into our starter code for this application. We have within the QA app a file called questionanswering.py. Now what we're going to do is just look at this code very briefly, but this is copied from the Jupyter notebook that we were developing on earlier in the video. We have this Astra vector store, which is an instance of the Cassandra vector store object from Langchain, and we're passing in some of the items we passed in before, such as the OpenAI embedding class and the Astra DB session that is instantiated with the cluster.connect method. Now we've put all of this code in our Django application, but this could very easily be extracted into its own application or its own Docker container that's dedicated to performing this vectorization and storing the vectors in the database. But for now, we're just going to embed this within the Django application starter code. And at the bottom, we have a function that we're going to call later, and that's called run RetrievalQA pipeline. This takes a piece of text and the number of documents we want to retrieve with our Astra retriever, and it's going to perform that retrieval augmented generation where it fetches K documents, adds them to the context that we're passing to the language model, and returns the result to our caller. So in order to build this process out, I'm going to start with the template here, which is the index.html template, and we're going to look at this second column that we created an empty skeleton for earlier in the video, and we're going to fill this out with a form element. So let's remove the comment, and I'm going to go back to the blog post to copy some code just to make this process a little bit quicker. This is the section on question answering with Django, Astra DB and Langchain. And you can look at this blog post to see the process that we're going to follow, but what I'm going to do for now is copy the code that we've defined in this code block, and we're going to paste that into this second column here. And actually this code should not have a second column for class, so we can remove that here and we can simply reference the code that we have in the blog post. So we have a column for second column here, and within that we have a form element where we are going to submit a user query to our Django backend. That's going to be done with a post request to a URL called submit question. We're going to create that URL just after we walk over this code, and because it's a post request, it's an unsafe method, so we're attaching the CSRF token to that post request for security purposes. Below that we have two fields in the form, and these are both text areas that are going to allow users to submit prompts and submit customization instructions. Now the first text area will have this label here, enter your query, so that's a question that the user wants to ask of the articles that we've got stored in the Astra database. And below that we have a second form element, a second text area with the label enter any instructions for customizing your answer, for example, answer in Italian. So this second text area will allow the user to customize the answer that they want to get back from the language model. And finally, we have a submit button below that. Once we've added that code, we can save the file and go back to our page. And on this page, we're going to refresh the page and we should now see a form appearing on the right hand side. But of course, we haven't got the URL for the submit question URL yet. So we're going to go back to VS Code now, and we're going to go to the urls.py file. And we're going to add a second URL pattern here, and that's going to go to a URL called submit. And that's going to call a view that we're going to define called submit question, and we'll give that the same name as we specified within the index.html template. So let's save that and make sure that that has the same name as what we have in the forms action attribute. Once we've added this URL, we now need to add the view that that's going to map to. So let's copy the name of that view and go to our views.py file and define a new Python function here that's going to take the request object from Django. And this Django view should only be callable via a post request. So at the top, I'm going to import a decorator from Django's HTTP module. That's the require post decorator, and we can then decorate this function with the require post, and that will mean that this function can only be called via a post request. Now within the body of the function, we're going to extract the prompt and the instructions from this form that we've defined. So if we go back to the index.html template, this is the text area here that contains the prompt that the user is going to submit to Django, and that has a name of prompt. So we need to get that name and we need to extract it here from the post request, which we can do by using the request.post attribute in Django. That returns a dictionary, which we can then use the .get function, and we can try and get that prompt out of the post request. And we're going to do something similar for the instructions. So let's copy that line down there, and we are going to go back to the index.html, and you can see the name for this particular text area containing the instructions. That has a name of QA-instructions, so we need to paste that in here and get that data from the post request. Once we've done that, I'm going to paste in a couple of print statements so we can print these to the terminal and verify that this is working successfully. And then we're going to set up a context dictionary here and add the question and answer values to this dictionary. So let's set up a key called question, and we're going to set that equal to the prompt, and that's because this prompt here was the user's question. That's what the user is submitting and asking about these documents that we have in the Astra database. Once we've done that, we can set another key in the context called answer, and for now we're going to set that to none, but later on we're going to set that to the answer that we're getting back from the language model. And finally, within this view function, we're going to return the render method and pass the request into that, and we're going to render a template called answer.html, and we're going to create that in a second, but we also need to pass the context into the render function here, and that will give the answer.html template access to the question and answer values. So let's now create this answer.html template. I'm going to go to the templates directory and create a new file, and that will be an empty file by default, but I'm going to go to the blog post and copy some of this code from the answer.html template. And we're going to paste that in here, and we can go over this code just now. So again, we're using a row class from Bootstrap, and we're setting some column system here. We're adding the question and the answer to paragraph tags, and that's going to allow us to display the user's original prompt or question, as well as the answer or the response that was generated by the language model. And finally, at the bottom, we just have a link that takes us back to the index page. So let's save this template and save the views.py file, and we're going to test this system out now if we go back to our application. So let's refresh this page, and you can see the page that we have now containing the articles on the left hand side, and on the right hand side we have a very simple form that allows the user to enter a query and is also going to allow the user to specify any instructions for customizing the response from the language model. So just to test out the structure of this, I'm going to enter a dummy query here. What day will Michael Vick appear in court? That's the same query we entered earlier, and we're going to submit that and see what happens. We get back the answer.html page that contains our original question, and of course at the moment we don't have a valid answer from any language model because we've not called any functions that are going to generate that answer. For now we have the answer set to none, but what we're going to do now is we're going to set up the pipeline that's going to call the RetrievalQA chain in Langchain. That's going to perform that retrieval augmented generation and generate a proper answer with the help of context from our Astra database. Now to start with, this is going to be very simple. If we go back to VS Code and we go to questionAnswering.py, we have this function here called run RetrievalQA pipeline that takes a piece of text. We're going to call that function now within the Django view, and we're going to pass the prompt that the user has submitted into that function in order to get back a response to that question. So let's clear out the print statements that we had here, and we're going to create a new variable here called answer, and we're going to set that equal to calling that function and passing the prompt in. Now in order to call this function we do need to import it, so let's go to the top of the file and I'm going to paste in the import here from the QA apps question answering module. We're importing that function, so let's save this. That's going to generate a proper answer from the language model, and the last thing that we need to do here is add that answer into our context in order to display that answer on the page. So let's go back to our application and refresh this page. We can now enter our query, what day will Michael Vick appear in court, and we can submit that to the server, and this time we're going to get back a template that contains a proper answer that was generated by the language model and returned via the Django application. And this is retrieval augmented generation as it was earlier in the video, because when we submit that prompt, the Langchain RetrievalQA chain is going to fetch the relevant documents from our Astra database and add them as context to the prompt that we're sending to the OpenAI model. So that gives us back a proper response, and if we go back to the articles, we have another chunk here about what Daniel Radcliffe is going to do when he turns 18, I think, and he talks about having a party, and he also mentions that he doesn't want to spend too much money on expensive items. So let's enter another query, what will Daniel Radcliffe do with his money? And we're going to submit that and see what kind of response we get. And you can see the response here. Daniel Radcliffe has stated he does not plan to be extravagant with his money. He mentioned that he likes buying things like books, CDs and DVDs, which are relatively inexpensive. So we're getting another relevant answer here from the language model that's generated by pulling out relevant data from Astra DB and adding that to the prompt that we're sending to the language model. Now that covers the query that the user is submitting. That is successfully working. What we're now going to do is look at this instructions part of the form, and we're going to allow the user to customize the answer that they're getting back in some way. Now in order to do that, I'm going to go back to VS Code and we're going to create a new file in this QA app, and that's going to be a file called PromptTemplates.py, and that's going to store a Langchain prompt template that we're going to use to customize the prompt that's being sent to the language model. Now what we're going to put in this prompt, I'm going to reference the Langchain documentation, and it's this page on using a retriever, which I'll link below the video. If we scroll down here, we have this section on custom prompts, and by default the RetrievalQA chain that's used here is going to add two input variables into this prompt template, and that's the context and the question. Now the question comes from the user, what is the question that they are asking, and the context comes from the retrieved documents from Astra DB. That is the supplemental context based on the user's query. Now I'm going to copy this prompt template and I'm going to paste it into VS Code here, and I'm going to clean this up a little bit so that we can see more clearly what this is saying. The prompt template has this text here. Use the following pieces of context to answer the question at the end. If you don't know the answer, just say that you don't know and don't try and make up an answer. Then we have this input variable of context that's added to the template, and we have the user's question here as well. Now what I'm going to do in this video is add a third input variable called instructions into this, and that's going to come from that additional form field that we have on the Django application. And then rather than explicitly hard coding answer in Italian, we're going to give users the ability to customize this themselves with these instructions. So the context comes from our Astra database via a retrieval chain. The question is the question that the user is going to input from this form on the front end here, and the other input variable is instructions. That's going to come from this second form field, and that's going to be added into the prompt template. Now once we've added that prompt template, I'm going to go back to VS Code, and we're going to go to questionAnswering.py, and that's where we have this function called run RetrievalQA pipeline defined. At the top of this module, I'm going to import that new prompt that we just defined, and that prompt is being imported from PromptTemplates.py, and that's the file that we just defined. So now that we have access to this prompt template, I'm going to go back down to this function that's calling the RetrievalQA chain, and we're now going to customize this further with the instructions that the user has entered. Now in order to get access to those instructions, I'm going to paste another keyword argument in here, and we're going to make instructions optional by setting it to an empty string by default. Now one thing we need to take note of here, if we go back to PromptTemplates.py, we're passing in 3 input variables, but the RetrievalQA chain is only aware of these two here, the context and the question. The instructions, it doesn't know anything about by default, and the way to get around this is we're going to take our prompt that we've imported at the top here, and we're going to fill it in with the instructions by using a function called partial that's defined on that prompt object. So what I'm going to do is define a variable here called partial prompt, and that's going to be equal to the prompt that we imported, which has this partial function, and we can pass keyword arguments into the partial function here in order to populate some of the input variables. So what I'm going to populate is the instructions, and we're going to set that equal to what's passed in as an argument to this run RetrievalQA function. So that gives us back a partial prompt, and if we go back to the Langchain documentation on using a custom prompt with RetrievalQA, what we can do is set up this dictionary here, which they've called chain type 𝗏𝗏. So let's copy that dictionary, and we're going to paste that just above the RetrievalQA call here, and we're going to change the prompt that is being referenced to that partial prompt that we're getting back on line 30 here. And again, if we go back to Langchain, we can see that we can pass in this custom prompt using a parameter here called chain type 𝗏𝗏. So let's copy that, go back to the function here, and we're going to add that as another keyword argument to the RetrievalQA.FromChainType function, and that's going to set that prompt equal to our partial prompt, and therefore when the RetrievalQA process is performing that retrieval augmented generation, rather than the default prompt, it's going to send this prompt to the language model in order to generate the response. So in order to tie this together, we need to pass this instructions parameter into this function here. So let's go back to views.py. We've extracted the instructions from the post request, so now we need to pass it in as a second parameter to that function. So let's do that just now. Once we've done that, we can save views.py, and we're going to go back to our application here, and we're going to fill this out with a custom query and also some instructions below. So let's enter a query here. What is the story about 𝗏𝗏𝗽𝗏? And we're going to take that example here, answer in Italian, and we're going to pass that as the instructions to our prompt. So let's submit that query and see what we get back as an answer. And you can see on the answer.html page, we have the question at the top, and this time the answer has been generated, and it's using that custom instruction to answer in Italian, and we're getting back that text in Italian here. And if we go back to the articles and redefine this query, and this time let's tell it to answer with a poem, and we're going to submit that. And you can see the response this time does contain a rhyming poem. In the world of football, a star did fall. His name was 𝗏𝗏𝗽𝗏, known to all. But his fame turned to shame, his image tarnished, as news broke of his actions, cruel and heartless. And just to finish this video up, I'm going to go back to our articles, and we're going to look at a few more of these articles. Let's again focus on Daniel Radcliffe. I'm going to enter a query, what is Daniel Radcliffe most famous for? Now we have these article chunks in the database about Daniel Radcliffe. Let's give it some customization now. We're going to tell it to answer with a haiku, and we're going to submit that order to the ChatGPT model in the backend. And you can see the haiku that we get back. Boy wizard with fame, Harry Potter is his name, magic in his veins. So the process that's being followed here is that we submit the query, and Astra DB, using that Langchain retriever object, is going to figure out what is the most similar documents that I have in the database to that particular query. It's going to return those to the caller, and those documents are then being added as context to our language model, and then we get back a relevant answer based on that context. That's retrieval augmented generation. We're now performing that within the context of a Django app that lets users submit a prompt and submit customization instructions for that prompt. And we're using the power of vector search and Astra DB under the hood to tie all that together. And that can enable some interesting and very diverse applications that integrate with AI chatbots and language models. Now we're going to finish this video with a very quick example demonstrating how we can write data to an Astra DB database. And the context that we're going to use here is that imagine we want to store all of the historical questions and answers that have been generated in this Django application. We want to store them in an Astra table called answers, and that gives us a historical look at all of the questions and answers that have ever been asked in this application. So what we're going to do in order to start that is go back to VS Code, and we're going to go to models.py and define a new model that's going to subclass the Django Cassandra model. So I'm going to create a new model just below the text QA vectors. That's called answers. Again, it subclasses that model, and again, it's going to be in the text QA key space. And we're going to add some fields to that model. To begin with, let's add a row ID. We're going to set that to a UUID data type, and that is going to be the primary key of this table. And below that, we're going to add two more columns, one for questions. That's going to be equal to a columns.text type. And I'm going to copy that to the line below. And as well as the question, we're going to create an answer column as well. And actually, let's rename this column to question here. So this table is going to take all of the questions and answers that have ever been asked, and it's going to store them in an Astra table called answers. Once we've got this model, I'm going to stop the Django development server at the bottom, and we're going to run a custom command provided by the Django Cassandra engine. So it's python manage.py, and the command is called 𝗤𝗵𝗽𝗁𝗓. Let's execute that command, and we're going to see what output we get back from this command. And you can see the output of the 𝗤𝗵𝗽𝗁𝗓 command. We have synced the two models that we have in this application, and this one here, the answers model, that's the new one that we've just created. So what we can do is go back to the DataStax dashboard for Astra DB. So let's load the browser here, and we have this dashboard. We're going to go to the text QA database that we created earlier on, and we're going to go to the CQL console again. And within this console, we're just going to verify that this table has been created. So let's select the key space here. And again, we're going to use the describe table command. And this table is called answers. If we execute that query, we can see we get back a response that contains the columns that were added to that model class. We have the row ID, the answer, and the question. So this table now exists within our Astra key space. What we're going to do now is go back to our Django application, and we're going to go to the shell and demonstrate how we can actually add a new row to this table using the model class that we have. So I'm going to copy the name of this model, it's called answers, and we're going to try and create an instance of that model. So actually let's look at the schema that we have in the model here. We have a row ID, which is a UUID column, and we have two text columns for the question and the answer. So in order to create a UUID, I'm going to use Python's UUID module and import the UUID4 function. And then once we've done that, we can use the model name, which is answers, and then we're going to call .objects.create. And for the row ID, I'm going to call that UUID4 function in order to generate a UUID and add it as the primary key of this particular row. Once we've done that, I'm going to give it a question. Let's just say test question. And finally, we can also put a test answer in here as well. After adding that code, we can execute the code and we get back this object here. What we're going to do now is go back to the CQL console here, and I'm going to clear the console out, and we're going to issue a query here to see if we have that row in the database table. So let's issue the query select all from answers, and hopefully we're going to see that row that we just added, and we get that back here with the question of test question and the answer of test answer. So we can use the model.objects.create function here in order to create a new row in the Cassandra table or the Astra DB table. Now the very last thing we're going to do in this video is exit out of the shell, and we're going to go back to views.py, and when we run this RetrievalQA pipeline, we get an answer back for the user's question. We're then going to store that answer and that question in the database. So let's go to the top, and from the models module, we're also going to import the answers class, and then we can use that answers class in this view function here. So after we've got the answer, we're going to call answers.objects.create. And again, at the top, we need to import the UUID function. So let's do that just now. We're importing UUID4, and that's going to form the row ID for this particular statement here. So let's call that function, and we're passing in the question, which is equal to the prompt, and the answer, which is equal to the answer that we're getting back from the RetrievalQA pipeline. So we're calling that, and that's going to save that new question and answer pair in the database. And that's all we need to do in order to get this working. So let's run the Django server, and we're going to test this out on the page. So let's now enter a query on this page. What will Daniel Radcliffe do with his money? and we can leave the customization empty and just submit that to the server and see what kind of answer we get back. And we get back this answer here, but what we're going to check now is we're going to go back to the Astra console here, and we already performed that select all from answers in the last query and we got back a single row. Let's now test if that's worked with the additional row, and you can see that we're getting back a second row containing the question, what will Daniel Radcliffe do with his money? And we also have the answer that was generated by the language model that's also been stored in this Astra DB table. So this has demonstrated how to perform write actions to Astra DB. We can simply create a model class that inherits from the Django Cassandra model, and then we can use that model and call normal functions such as create in order to create new rows in the database. So that's been all for this video. We've demonstrated a lot of things that you can do with Astra DB in this video. We've seen how we can generate a connection to Astra DB from a Langchain application and also from a Django application. We've seen how to use Langchain's Cassandra integration in order to generate vectors and store those vectors in an Astra database table. And we've seen how to perform retrieval augmented generation with Langchain and Astra DB. As well as Langchain, we've moved on to Django, and we've seen how to build a very simple Django application that makes use of language models, Langchain and Astra DB in order to let users submit questions and get answers based on a set of documents that are stored in our Astra database. We've seen how to fetch data from Astra DB using Django, and we've seen how to display that on a page. And we've also seen how to write data to Astra DB using a Django application. So that's all for this video. Thanks for watching, and thank you to DataStax for sponsoring this video. If you've enjoyed this video and you'd like to see more of this content, let me know in the comments. And don't forget to give the video a thumbs up and subscribe to the channel, and we'll see you in the next video.